Okay, the recording just started. So, because we have some time, I've managed to put 3 lessons a week. I know this week for me is a bit more difficult, but we have 3 lessons this week and then 3 lessons next week. So I will take the time to be sure that everyone is able to run notebooks, to run the code, because machine learning is, of course, coding and running models. And if you're not able to do that, this would be very unuseful. Is there someone speaking now? Okay. So, first question, what do you have installed to run the notebook? So, do you have Anaconda installed? Could you please respond this in the chat? Yes, so you have Anaconda. Okay, good. What I could do, if someone wants to, I don't know if you don't want, it's fine too, but does someone wants to share the screen so we can go through one person having a problem and with everyone? Is someone agree with that or not? Okay, so I propose someone share the screen. So when I see people saying yes, so perfect. So I think this is a good idea that we go through the problem that someone has, then and please put your microphone so we can have some dynamical practical session together. Hi, Daniel.
Yes, hi.
Okay.
Okay, yes, I can share, of course.
Okay, nice, perfect. So then we can see why it doesn't work, or maybe you don't know how to proceed.
Yes, so let me share my screen, and we can use it as an example for
everyone. Perfect.
So yes, for everyone. Okay.
So, I mean, the idea here, so that people know, is really to be both. So some lectures will be more. So the last one was quite theoretical, and so I propose today to be more practical sessions, and so to just work together on some code.
Yes, so mostly I work on a Unix system.
Okay.
So, and we have, of course, installed the Anaconda.
Okay.
And we have everything that works, and we have Jupyter Notebook that
okay, nice.
Installed. And so, as an example, if I can, I go to Python, Python 3, then Jupyter.
Okay.
Jupyter. What is happening? Python. So Jupyter.
After you, we can then go to the Windows example. So we have we do both. So this is a good for people having Unix. Please look how we proceed.
Python. I don't know why my Python now is not working.
But anyway, in this kind of way, you can just
okay. One token Jupyter. I don't know why it's misbehaving.
Okay, when could you please type the following?
Yes.
So you type Jupyter.
Yes.
And then dash. So yeah, notebook. And enter. Okay.
Yes.
This way. Try this.
Yeah. Let's see. Yeah, this works. Sure.
Okay. Yeah. So people that have Unix, you can try this in command line. So this will open in your browser Jupyter Notebook. Okay, nice.
Then
now you can go to the folder where you have downloaded the homework.
Yes, we have been working on. We created this, and we've been working on one of the folder. I put them desktop.
Okay. So what I suggest you is go please to the browser.
Okay.
And normally the other tab, so the tab with home, can you just check? So I mean higher. So you see higher. So on all the let's say the Google tabs, the tabs from your browser.
Which?
Home, the above.
This one.
Yeah, this one. So this one. So I guess you have run it in. So there should.
This is desktop.
The desktop. And where did you put the?
Is from here.
Okay, so you can click there.
Yeah.
Click there.
Yeah.
Okay, and where is my assignment then?
That one I missed. I haven't finished doing it.
So you don't have the download of my notebook, or do you have it somewhere in downloads?
No, that one I don't have.
Okay, so maybe you can download it and put it somewhere so we can open it.
From the email you sent,
yes.
right?
So you go to emails and download.
Yes. The previous email you sent.
Maybe
this one.
Can I share a file? I could also share the file with the Zoom. I don't know how.
Yes.
You can. No, you can see it there. Okay, you have it. You have
this
it.
one here, right? Yes.
Perfect.
Super. So
you download this. Yes, you download that.
Yes.
Save file. Great.
Yes.
It's a zip, by the way, so you should open it.
Yes.
Where is it?
Is this
okay,
one?
I know. Ideally, what I would do.
I take to the same folder.
Yeah, you can put it in the desktop somewhere. So where you prefer.
Yes, I think I should put it into the same folder we are.
Yeah, that's up to you. Huh?
Yes. Here. Yes. And extract it.
Okay, great. And then, did it work?
Okay. Yeah.
Okay, now if you go back to the, you can find it, I hope.
Yes.
Okay. Yeah. Where is it?
This one?
Oh, yeah, perfect. Yeah.
Yeah.
Okay, open this notebook.
Yes.
And there you go. So there you know you should have the notebook opened.
Yeah.
Okay, and so the most important thing is, can you run the first cell? I guess you will have issues with libraries.
Okay, let me try to run it.
Yeah, try to run it.
So no complaint.
Seems to be fine.
Yes.
Okay. And so, okay, there we go. Normally now you should be able to do the assignment.
So there's the second with.
Yes, that's my fault. So in that case, so PD is Pandas. So what I suggest to all the people who have this issue, and I guess everyone should have it because it's my fault, you go to the first cell.
Okay.
And you add a line which is import pandas. I will type it in the chat. So it's import pandas.
Yes.
As PD. So pandas is a library that is often used in data science.
Yeah.
It's very common. You will see it a lot. PD. It's something that works with data in a kind of table form. So you can read from Excels. You can read from CSV files. You can read from different formats with pandas and play with the data.
Okay. Yes.
Okay, so try now with this line. If it now works.
Who's the second?
So no. you have to rerun, of course, the first sounds.
Sure. Okay.
And otherwise,
trying to run.
Run
Try
this.
to run.
Okay,
yes.
it works. Okay, first comment I can say to people. To go faster, if you don't need to click on run, what you can also do is hold Shift plus Enter.
Enter. Yes.
This is a quite good thing to know.
Yeah.
Okay. Yeah. And so if you run the next cell, I guess it's not yet done.
This one.
Yes.
It doesn't complain, so it run.
Okay, it works.
Yeah.
Okay, perfect. So I think you are fine to go through the notebook, right?
Yeah.
Any other questions? Okay, so does everyone on Linux manage to open it without issues? Please answer in the chat. Seems okay. For Windows, who has an issue with Windows? Yes, fine, I see. So I will wait a bit to see if everyone, okay, perfect. Okay, so I think now everyone is, me. Okay, Jean-Baptiste, you can probably, so if you have issues, you can maybe share so I can see through, and Colette too, I see has an issue.
Should I stop sharing for him
Yeah,
to share?
probably you can stop sharing for now.
Okay.
Okay. Okay, so Jean-Baptiste is sharing, great. Okay, Jean-Baptiste, what's the problem on your side? So I don't hear you. Maybe you're muted.
Can you hear me now?
Ah, perfect. Yeah, now I hear you.
Okay. Yes, I run the first cells and it goes, but the second cells that is move on.
Okay, so can I see the error? So permission error. And can you scroll a bit down to see what's the problem? Blah blah blah. Down. I guess permission denied. Okay, and you're on Windows, so I guess the CSV file has not the right permission to be read, which is strange. So I know how to move permissions in Unix, but in Windows, maybe what I could suggest you to do is try to open this file with, so you go to the files where you have this and maybe try to open with the text editor to see what if you have access to that or not. And then maybe save it again. It's strange. I mean, apparently it's a question that this file, you don't have the access.
Yeah, hello, please, could you scroll up to the cell for reading the data? Let's check whether she made mistake in trying to read.
Yes.
Because I'm using Windows and I don't have any problem.
Okay, so it's working. So can you see in your folders the file to see what's wrong with the file?
Yeah, this is a file.
So you go through, I don't remember, I don't have Windows, so it's what is it called? It's called Explorer, I think.
What I did was I just used single quotes and I went to the data direct, like data.csv. So I didn't put any data/data.
Sorry?
Maybe if she can. I said what I did was I went to data.csv direct and I used single quotes.
Ah.
I didn't put data/data. Can she try that? Yes.
Signal quotes will not change anything. That's not the issue here because it's not. You can try. You have the same. You will have the same issue because it's a permission error. So I would suggest.
Yeah, but exactly. Yeah.
I don't know what you think. I guess it's just a copy paste mistake with permission that changed or something.
Yeah, it works. No, it doesn't. No.
No, of course it doesn't work because it's. I mean.
Yeah.
It's
one thing what you could do is maybe find the folder and right-click it and try to change permissions. Maybe that will work.
Yeah, exactly. I don't know how you do that in Windows.
I think in Windows, if you right-click, there should be a button that says change permission for the file or something.
Okay, so Jean-Baptiste, in fact, what you should do is, I don't know if you shared the whole screen or you just shared your browser, but I need to see the file itself. So you need to go to the Explorer and then right-click on the file, on the data file. So the data is a file that you have on your computer.
Yes, Prof.
So that's the point. Maybe the file is not there.
Say right-click property permissions. But I think he's not sharing his whole desktop, right?
He's still sharing his desktop.
That is it.
So Jean-Baptiste, do you hear me?
Yes, I can, Prof.
So I don't see, I don't know if you have the file before you right now or not.
Which one?
So can you share the whole desktop maybe, and then you go through the folder. So to go through the folder where you downloaded the homework. So not the notebook. So you go to the menu of the Windows PC and you go to, and yeah, and we don't see it. That's the thing. I think you have to share again your screen.
This is the folder.
Yeah, can you please stop sharing and share the whole screen, not only the Chrome website. So you share the whole screen. You share the wrong thing. So stop sharing. Okay. Wait, let me.
Yeah.
Okay, I will kick you like this. Can you share again your screen? And please share everything, not just the window. So you have to share screen, then select desktop.
More advanced techniques that will be built up.
Sorry?
Yes, good.
Okay, I now share again the file. I guess it's the same as before. Okay, so I will just say what you have to do. It will be easier. So I think someone said it in the chat. You have to go to the data CSV file. So please go there, right click. Okay. And then when you right click, you go to property and then permissions, apparently. Is it okay for you not to do that? Jean-Baptiste.
Yes, Prof. Yes, I did it. I think I will try it again.
Okay, perfect. Okay, there you go. Perfect. So you should be fine now. Anyone having other issues? So I have some error to name error, name sorted features is not defined.
I think it's good now, Prof. So.
Okay, thank you for sharing then. Thank you.
Okay.
Okay, I think we are fine. Everyone is able to open it, except that okay, there is an error apparently. So I guess there is one variable not defined. So maybe it's an error again, a fault from my side. So what I will do. Wait.
Pardon, I'm using Windows 10. I'm not also able to open.
To open the notebook or to run the notebook?
The exercise file.
Mm-hmm.
I'm not
Okay.
able to open it via Windows 10.
Can you share, please, so that we can go through the...
Okay.
So in the meanwhile, I will check about the name error. So I guess it's just a variable. Name sorted feature is not defined. I removed some code to fill you in, and maybe I removed not everything correctly.
From here, how to?
Okay, sorry. So now you should go to the folder where you downloaded the exercise. So I guess it's maybe in downloads, maybe documents, depending. So you got the email and then you download it somewhere, I guess.
Download it here.
Okay, so now you have to look where you downloaded. So scroll down, don't see. It should be a folder, right? Should be, so go down.
No, it's not here.
So
how from here, how can I go?
So the first thing you should do is
Yes.
download the file from the email. So you go to the email and you download the file somewhere.
I downloaded the file, but from here I cannot move to the partition D.
Partition.
Just leave it.
Okay, that's a good point. That's because you launched the computer on. Yeah, you launched your Jupyter on another drive, so it's not able to access. That's. So I would suggest you to download again or move it into the downloads or documents. The other option.
Okay, now I can go.
But I would suggest to move the file to the C drive.
Okay. Any place in C?
Yeah, you can use. So put it in documents, put it in downloads, put it somewhere.
Copy. Download.
And then it should work. So let me check now the other issue.
Now it is in download folder.
Okay, go to downloads now in the Jupyter. Yeah.
Okay, yeah. Just a minute. Jupyter documents.
I don't.
No, I cannot paste here.
No, you need to paste. What you can do is click upload. I think if you upload, no, you have to do it in the. You have copy paste in the other one in the Explorer.
Okay.
You cannot copy paste in Jupyter.
Yes. Now I copied it.
Okay. In what? In documents?
Windows documents, you mean, or Jupyter documents?
Windows documents.
Windows documents.
I mean, in fact, it's very simple, and the idea is that you have some
now it is
folders, and then
yes.
put it somewhere, and then you can see it back in Jupyter. So okay, it's fine now.
Okay, in Windows now it is in Windows documents.
Okay, refresh this page. Yeah, click again. Documents. Okay, so apparently you don't have. Again, because apparently when you share the screen, you don't share everything. So I don't see the file structure of your computer. So I don't know where it is.
For me, I click upload and I
Okay.
went to pick it up from where it was, and then it appeared here.
So upload works, right? Okay, so
yes,
then okay, you can explain.
Yes, if I click upload at the top, it takes me to my folder, to the page where I can pick.
Upright, there's upload.
Upright. You see, and not right. Yeah. You have right.
Right screen.
That's the difficulty of giving lectures at a distance. So upright, totally upright.
There's up. Yeah. What are you doing?
Top.
Not that's left. Go to the right. That's
right.
left. Go to
Right.
the left at the top.
Tap escape and then go to the right.
It's at the top where we have log out.
Yeah, you see.
Type escape.
Right.
Right
Or-
where we have logged out.
Can I put a drawing?
No,
or something?
type escape. You don't have this thing showing. Yeah, exactly. So to the right is upload. No, up. My goodness. There's up. Yeah,
Next to new. Next
Next
to
to
new.
new.
exactly. Next to new, top right.
Right side.
Yeah. Upload. You see upload?
No, on the right. Do you see upload?
Not right click. We mean you go to the right of the screen. You see, you go to the right of the screen.
Maybe let's try this. So go to the top right corner of your screen. Top
Top right corner of your screen. There's quit,
Top
log
right
out,
corner.
there's upload, there's new.
Go to top, yes. Go again. Move to the right again, yes.
Below.
Now come down a little bit. There is something written up
Yeah.
upload.
Upload,
Yes,
yeah.
there you are. Perfect.
Nice.
Yes, now it is.
Okay.
Yes,
I mean,
now you have to find your file.
That's the difficulty of not being able to be at your computer. Eh? And now I should.
No.
Session 1.
That session, yes.
And can you also maybe you have to have the data too, so you have to do it again, upload.
Then you have upload again.
This
Click
one you
upload
mean?
again.
Go up
blue
again
one.
and click upload.
Yes.
Yes, there.
The
Here,
blue
here.
one.
Down there. Between the cancel.
The blue upload.
No. Cancel it.
Okay.
The blue one is written yes.
Upload here. This one.
Super.
Okay. I never did that like this.
Now go down and find that file. I think it should be at the bottom. Or alphabetically, I'm not sure. Session 1, go down.
Nothing.
No, don't click documents. Just find that file. No.
Just go back.
Yeah.
Go back.
Okay.
Where
Let's
you
do it
found
this way.
documents, go down to the end of that list, that long list. Move
No.
away from documents.
Let's do it this way.
No.
Sorry,
let's
everybody.
upload.
I will help him to do it.
Yes.
Maybe I'll go into a breakout room and we can do it together.
Okay.
Because Pierre-Paul needs to continue with the class.
Yeah. So what I suggest to do, guys, so either if we have some time at the end, we can go through that, and so people who are fine can leave, because otherwise we keep up everyone. And I will now maybe just check the issue about the name error, because this is quite, I think, an issue that everyone will have, right? And then, because we have so many problems, I will not correct it today. I will leave you, I think, the weekend and a bit of time to make it work. And we will correct it probably next week. And so I will then give some theoretical lectures about the next model we will see. Is this fine for everyone?
That's good.
Okay, let me just share my screen and show you the notebook. So we do that first. Okay, Zoom is really annoying because you have so many different windows. Okay, here, share screen. Okay, sure. So can everyone see my screen?
Yeah.
Okay, so like I said, it's you should have something that, okay, let me just change the kernel. So, okay, this was the first error you probably all got. So you have to import pandas SPD. Sorry for that. And so where did you have the next issue? It's around the, this is fine, insert the code. Let me just check the chat. Section 1316. Yeah, of course it doesn't work because you have, sorry, can you please, wait, it's Colette, I think. Someone is making noise here and should be muted. Could you all please mute your microphone? So I will mute, I can mute it, okay, perfect. Okay, so the idea is, in this exercise, you will need to sort the features according to their linearly with the target vector. So the idea is that yourself, you will visualize, you make what's called univariate plots. So you see how each feature, so we have seen what are features, how that feature, we're not able to read the code. You can't read it? I think I'm sharing my screen, so it should be fine. So the idea is that you rank the features according to their importance. So you look at the plots, you see, okay, this has visually, so we will see later that there are techniques to correlate these things. Yes, maximize the font. Okay, sorry. Yeah, but I mean, in any way, it's not that important. Okay, I mean, it's fine. The idea is that the error you get about sorted features is not existing is because you have to define this variable. So please define that variable among their linearity with the target. And sorted features is a list. So it's a Python list. You know, you have seen, I think, that the Python list is defined like this. And so you put the features that then will be used in that section. Okay? Any other questions about the homework? So if not, I will let you make this on yourself. And now we will go to the next part. Let me share my slides. Okay. So as a quick recap, we have seen together what are features that are really essential to machine learning, how you need to have a wide variety of features to describe.
Hello.
Yes.
Can I ask, are we supposed to be able to solve the homework after the last session or after today?
You should be able to solve it after last session. So you should have everything to solve it.
Is it possible that you just explain to us quickly the code?
Okay, so what does seem for you too difficult?
I think I took the first part with Omelu, but I think there are things that I didn't get from this code. I know that we call the libraries, and then I'm not really sure that I understand the structure of the code. If it is possible that you just quickly.
Yeah, I will first try to make the font larger so people can see it. Just give me 1 minute. Okay, zoom in. Okay. Can you read it now?
Yes, can read.
Okay, so let me go through the code. So here you read the data. So that you have seen with pandas. Here, what's happening is that we define the different features. So they have name, like the age, the sex, the BMI, etc., of the persons. And then I suggest you, and okay, I mean, there are a lot of things to master. So please, if you're not familiar to the pandas package, you can quickly go to the web and see how pandas works. But basically, df is a data frame. And if you put brackets with a variable, you can access that variable. And when you put dot values, you get a vector that has and here it's even a matrix with all these data. So you have a matrix with the samples as the lines, and the columns are these different features. Okay, so the shape is a property that will return you the number of lines, so the number of sample, and the number of columns, the number of features. We do the same for the target. Here we get the target. And here, basically, you plot each of the features as X, and as Y, we look at the target T. So this is what we want to predict in function of these things. Okay. I think I already, in fact, yeah, I already did this part, in fact, so for you. So I use plot scatter to make these plots. So now you should find the one that are most correlated. So in fact, I see I already did it. So with this, you have the most correlated features. So what you do is you have to list yourself here. So I know, okay, sorry, I'm just skipping, where was it? No, not here yet. So here it's just okay. So this is already done. And then we have to find the solution to a linear regression with the pseudo-inverse methods. So what you have to do is first do univariate regression. So we have one single feature, and here you have to insert the code that implements the pseudo-inverse. So I've already put the beginning of the solution here. You have to just complete this line. The coefficients are sum inverse. So this is, again, when you don't understand something, type it in Google, look at the package, and there's always an API. So for instance, you don't know what this is. This is the best way to learn fast. You go and then, let me just, okay, you put it in Google and then you can look at the package and it explains how it works. It's compute the multiplicative inverse of a matrix, blah, blah, blah. And then you can use it. You have examples here. And then you can use it here to compute the inverse. We have seen in the course that we want to compute the inverse of something to get the coefficients. And then the prediction is, again, we have seen it's a dot product between two matrices. Okay, here you have to define a function that computes the root mean square error between the prediction and the target. So you have two vectors, okay, and then you have to return a single number that gives you the root mean square error, how good the fit is between that and that. Then here, this section is about multivariate linear regression. It's now you have not a single feature, but you have two or three. So I think we, yeah, 1, 2, then 3. So the idea is that you just do the same as before, but we extend the number of features. So, and then here you have to fill the name of this. So you should first put, so this is the lowest correlated. So you see here, there is the correlation. This one is the most correlated. You see clear line, so you should put BMI as the first feature here, okay? Like this. And then you order the things. And then we will see, and this is the idea of you to see what happens when you include more features. And you can, of course, play with different features and see how it works. Here is a bit about train test. So I will just skip this now because today we'll see a little bit about train test, but normally you can do it. It's basically you will split the data into two parts. And here you implement this gradient method. We have seen that we can compute gradients and go through the optimum by updating each weight. So we do weight minus alpha times the derivative. Remember that? And then this is what you have to put here. Okay, and then you can play a bit with this. Okay, so I know it's not easy because it's a lot of new Python code and libraries. I want you just to try it, to read the different functions. Go, like I explained, you go to Google, go to the API, so the libraries, to see how it works. And I will correct it together, and then I hope that when we correct it, you will understand. Okay.
Okay, thank you.
I have a question, please.
Mm-hmm.
I already tried to work on the notebook.
Yes.
So there are some problems there. For example, what I can see here on your screen about the inverse. That inverse is not working. I don't know why, because the matrix is symmetric. So it's only when I try to read online to find out that it's only when you put P inverse that is working.
What do you mean that? What do you mean that P inverse?
Yes.
There should be a square matrix. So you should. I mean, we can go back.
Yeah, it's a square matrix because I even tried with simple square matrix. I think the problem maybe is because it's
bad conditions or
matrix maybe because I put with my hand just a 3 by 3 small matrix and it's still not inversing.
What's the error?
The error is something I don't remember unless maybe I go back to try. I said matrix. No, I don't remember exactly.
Okay, so
unless I open my.
Normally it should work, but I mean, it's not a problem. Don't be afraid if it doesn't work. We will go through it together, but I'm happy that you already tried to inverse something, okay?
Yeah, I tried it. P inverse is working. Now what I want to understand is maybe a bit down there. If you can scroll a bit. Scroll again. Yeah, it's this part of exercise.
Here.
Create one, yeah, this one. Because I created one variable linear regressor. That is what we coded before.
Yes, exactly.
Yeah, but what is this one now? Should we create another class for the two variable or
No,
is the same one?
No. Because this one should be normally should be general enough to take any number of features. So it should be 1, 2, 3, 4 should work because it just depends on the shape of X. Okay.
Okay. So this question meaning I have to create another linear with two features.
Exactly. Yeah.
Okay.
Okay. So I will stop talking about the homework, otherwise you will not continue. Okay, but it's good to go through the issues together because it's not easy in the beginning. Okay, so we have seen the features. We have seen difference between classification and regression. So the one is we have discrete labels. The second one, we have a continuous range of targets. And so the linear model, like the most important point to remember here is that we have an exact solution in terms of minimizing the square error with this here. So you have to inverse x times x transposed times x times t. So this is what you have to code. And the second solution is the gradient descent, which is often done in a lot of machine learning algorithms, is that you compute the gradient and then you update the weights with the old weight minus alpha derivative of the loss function with respect to your weight. Okay. Any questions about the course itself? Okay, so the next topic is classification. So what does the linear model? We have been able to predict a value that is continuous with respect to the features. But imagine you want to do the following problem. You have two features, x1 and x2. It can be again the length and the color of your fish. And we want to identify the green points and the red points inside this feature space. One thing we could do, if we still want to use a linear regression model, is say, okay, these points, it's like a normal point like before, but we say that these points have as target t -1. So we put -1 for these ones. So if you have this input, I want to predict -1. If I have this input, I also want to predict -1, etc. But if I have a point here, I want to predict t equals 1. So that's one thing we could do. You put the matrix with the target. So here you only have 1, -1, 1, -1, and etc. And then you do a linear regression. through the sum of squares criterion. So because you do that, and because we are here in a two-dimensional space, you will have a line that will fit each group. So you have one line that will try to fit the closest to t equals -1, and one line that will fit all the targets equals 1. Because we have as loss function, remember that E equals target minus the prediction. So I will put it like this. So this is the difference squared, the sum over everything. And then we had also 1 over P. Because we have this loss function, what we really do in practice is we want to minimize the square distance. So this line is the best line that minimizes the sum of all these differences squared. The same for this. And because we do that, we also have a line where t equals 0 that basically is the separation between the two classes. So we have the red points and we have the green points. Okay. So technically you could choose any alpha, any line as a separation, because you know if you change this A, you have different lines here that separate the two clusters. The common sense is to put 0, because 0 is just between 1 and -1. So we have now found a solution to address a classification problem with a regression model, so with linear regression. So we can do classification with linear regression. So, yes?
I have a question. What if the range between those points and the line are not the same?
What do you mean? What is the range between these points?
The distance, dot t. We are considering on one line as -1, on the other one is 1.
1, yes.
So what if it is bigger than 1 and -1?
So why we choose these values? That's your question, right?
Yeah.
Okay, so technically you could choose anything because it's just a choice. I just decided to put 1 and -1. You could put 0 and 1s. This is something people also do, but then your separation is 0.5. So anything will work. You should keep in mind that the separation is the half of the two extreme values. Okay, so if you put -2 and 2, it's still 0. If you put 0 and 1, it's 0.5, etc. So you see the idea is just you just define a set of lines mathematically, and so you just put the half point as difference. But one thing that is important to see is that, as you will see later, this is not the best idea to do this kind of linear regression for classification, because what we do here, and this is exactly the next slide, we do not minimize the misclassification. Remember, when you do machine learning, you want to minimize a loss function. And what we tell the machine here is we want that the machine minimizes the sum of the square of the distance. So it minimizes only this with respect to some line. So it makes the best line here, the best line there, and then you decide that the separation is this line. So the line W transposed X equals 0. So if you have this scenario, so imagine we have blue and red points, but the reds are quite distributed. Our algorithm, so the machine will choose to put the separation here. Is this a good idea to put it here? No, because we have here 2 points that by the machine will be seen as blue, because it's on that side. It's on the blue side, so this is the blue side. So these are seen as blue, and the other one are seen as red. In fact, there could have been a better solution. There could have been this line that is perfect. And so we missed that line because intrinsically we minimize the sum of the squares. So it's not a good criterion for classification task, but still it is widely used for its convenience. So you can still use it. So it's the idea here is to show you it's possible, but keep in mind they have some limitations that are intrinsically related to the idea of taking the sum of squares criterion. Okay? Good. Of course, I mean, here I've showed you that there existed a perfect solution to this problem, but it's not always the case. Imagine that the blue and the red are in fact covering each other. There is no linearly separable line that finds the best solution. So this is possible. So why is this here the case? Because we only have two features, and sometimes a possibility is to go to higher dimension where adding features can sometimes make the problem linearly separable. Okay. So I will not introduce the perceptron today. I will use it next week to introduce the neural network. And so what time is it? It's 3 p.m. What I will maybe do. Let me check. Yes, I will introduce another model for classification, because right now I think it's a good point to introduce this new model, because we have seen this classification task and the limitations. Because we minimize the sum of squares, we can sometimes have issues where we don't find the perfect boundary. So the next topic, and I don't have slides for this, so I will take just a blank page. I will introduce logistic regression. Okay, because this file is so big, it's not working. I will make a new one. Just okay. So I want to go back to the classifier that we know. It's the classifier that does linear regression classification. So suppose we have a one-dimensional problem. So we have here the features X, and I put here the target T. So if we have some points here that are 0, so this is one class, and then we have a set of points, let's say here, that are ones. So if you use a linear model, there is no issue, because what we do is that we fit the center of this cluster. We again minimize the sum of the squares on this cluster. We minimize the sum of the square on this cluster, and then we put a line. At 1/2, we put a decision boundary, so it's here. And so every point that has features smaller than this value is seen as a red class, and every feature that is above is seen as a blue class. So this works perfectly. But imagine that we just change one point. We change the blue to have one sample here. So the idea is that there is a fish, for instance, that has a very high feature that from that class. If you use the same procedure, we fit one point here with the linear regression. We fit another point in the center. Because of the sum of square, we are attracted to that point. So the center will maybe be here. And so if I put now the line, I'm like this. 1/2 is there. And so the decision boundary is problematic, because these 2 points are seen also from the red region. So it's an issue, and these are correctly classified. But we still have 2 points that are not well classified. So what we will see now is that with logistic regression, we have another approach where we will not fit a straight line. We will fit a sigmoid that basically go from one class to the other like this and smoothly classifies features with a totally different loss function. So instead of minimizing the sum of squares, here we will minimize something else that will be such that we have a much better classification performance. Okay, let me go through this part. So the idea of logistic regression is to say that we have two different classes. We have the C1s that are maybe the red ones and the C2s that are the blue ones, let's say. And so we say that there is some probability, P, to have class 1. So that the class is 1. And then the probability 1 minus P is the probability to have the other class, the second one. And so each point has some probability to be red or blue. And we define the odds as P over 1 minus P. So it's the probability to have P over not having P. So if you have a 50-50 chance, it's 1. If it's, let's say, 2 over 1, you have odds that are 2. So it gives you how probable P is, so how much probable you have class 1 with respect to class 2. And the logistic regression model just says that the logarithm of the odds, so it's log of P of over 1 minus P, is a linear model. This is linear. So it's like we saw before, it's WT times the feature X. And so, because we have this relation, what you can do is say that the probability, so you isolate mathematically P, you can, I will not do it here in detail, but you can do the exercise, you will see that it's 1 plus, so E exponent WTX. So you have basically a logistic function of a linear model. So this equation, let's make a graph of it. So what we have, imagine that this part is very negative. So you have something very negative. So this is very positive because I have a minus, and so this is very big, and so I tend to 0. So as long as my linear model is giving something small, I have a small value around 0. So let me just change this. I will put it here. So I have 0, 0, 0, 0. You see that when this becomes 0, I have 1 over 1 plus 1, so it's 1 over 2. So I have a half. And then it keeps increasing. And at infinity, you have minus infinity, so 0, and so you have 1. So it goes to 1, 0. So the idea here is that we basically have a linear regression that then goes through some kind of activation that maps everything between 0 and 1. So from the last model, we have seen that. And I will picture this as let's say some kind of neuron or perceptron where you have the let's say, different features coming in. So you have x1, x2, x3, each time with the weight. This should be 1, sorry. So you take, so this is the linear model. This is a linear model plus some bias plus b. And then what you do is that you have some variable z, and then you do 1 over 1 plus e exponent minus z. And this is this activation here that maps everything between 0 and 1. So the idea, you see that we have this linear model, but then we introduce this nonlinear function where we map everything between 0 and 1. Okay? But what's important here is that we see the output as a probability. So this is a probability to have the feature x1, x2, x3 as class 0 or as class 1. So here it's when the probability is high, we can say, okay, it has a high probability to be in class 1. So we are still close to what we've done before. So the idea is that we still have the linear model, but we have introduced this nonlinearity. And now comes the most important part, is that because we say it's a probability, probability here, this is when I started, I spoke about odds, I spoke about probability, is that we will not minimize the difference between the target and the prediction squares. So we will do a different optimization that is much more following the probabilistic approach. So the idea here, I will write it down. So I've explained this, okay. So maybe one thing I forgot to say, another way is if we define sigma as this nonlinear function. So if we say that sigma is this, we can say that my logistic regression function is the following one. So this is the equation for the logistic regression. And then we have defined the model. Now we have to define what is the loss we want to minimize. And so we want to maximize the likelihood of the observed data. So this is again a bit a statistical approach. So I will derive it for you. So, okay, you will see it's an idea to apply some concepts to an equation. And
I'm sorry, what's the difference between P and sigma?
What is the
difference between P and sigma? P, the probability, and sigma, what is the difference between them?
Sigma is a function. It's a function that It's a function that takes a variable z as input. So sigma.
But it's the same. I mean, it's the same equation like the probability, isn't it?
Sigma is this. It's this function, and p is a probability. So small p or big P? Small p, I guess. Small p is a probability to have class 1. Okay.
I'm talking about the go down, please. Here, P is equal 1 to divide by 1 plus e to the minus transpose omega x.
Yes.
But I think the same like sigma, isn't it?
Yes. So this is you can. Yeah. Sorry. So p is this, and basically, so the probability is given. The estimated probability is given by my function here. Okay. So p equals sigma of WTX. So this is correct indeed. Okay. So I mean the workflow of the model is given here. You have the different weights and then this activation. So what I do now is to say that the probability of having t given some data and the weights of my linear model, so the weights of what I've defined here. Sorry? I will mute. Okay. So again, this is my model. And so if I put here my model of x exponent t times 1 minus my model x exponent 1 minus t, imagine that t is 1. So then I have the probability of having class 1. If my class is 0, this is 0, so it doesn't take into account, but this then becomes 1, and I have the probability of having class 0 because I take 1 minus my function. So this is the probability of having 0 or 1 given my data. Okay. So now what I do is I define a function which is the likelihood, and the likelihood is something that maximizes the probability of observing each of my data points. So if I take the probability of seeing my data point, I want it to be maximal. And so what I do is I replace it by this change color by this equation. So it's the sum product of this. So this is how likely I have seen each data point, and I take the logarithm, and this is often done in machine learning. I maximize the log likelihood. So I maximize the log of this, and when we take the log of this, we have t log t estimate. So it's my estimate of my function. Okay, and so this equation is the one that we will use in logistic regression that we want to maximize. So if you want to maximize this, you want to minimize minus this. So the loss is minus the log likelihood. Okay? So don't worry. The idea here is that you see that we want to maximize something that is very different. So you see that here, it's totally different from the sum of squares. And let's try to understand this equation a bit more, because maybe if it's the first time you see it, it seems a bit strange. So let's suppose we have our target is 1. So we have class 1. So this is the first thing we can have. In that case, my loss is what? It's equal to minus t log t estimate. So this is what my function is giving. And this part here is not there. It's 0 because it's 1 minus 1, 0. So this is not there. So I want to minimize this function. And so if you make a graph of this, so the log is something like this, which is 0 at 1. So if you take the minus, I have something like this with a 1 here, and everything up to 0 goes to infinity. So what's happening is that I want to minimize this. So I want to go to 1. So my model is pushing me to go to 1 when the true class, when the true label is 1. So 1, I know that t is 1. I want that t hat, so the estimate, goes to 1. So this is good. My model is going to 1, 2. But it's going as a logarithm to 1. And we see that we have exactly the same happening when we have the second class. So imagine that t equals 0. What is the loss? So you fill in 0 here. You have not this, but you have 1 minus 0 is 1 of this. So let me write this down. You have log minus log, because we take the minus here of the log likelihood. So it's log of 1 minus t hat. So here, if I make a graph of this, so it's an inverted shifted logarithm. So for sake of time, I will write it here. So be convinced that it looks like this. And so you have a 1 here. And if you take the gradient of this, you want to go in that direction and so go to 0. And so, of course, if the true label is 0, the loss is driving the model towards 0. Okay, so this is something I mean, this part is not essential to understand. The important is to know that the loss is given by this equation here, and that you should be sure that in both cases, the model is pushing the weights to the right direction. So if it's a 1, it goes to 1. If it's a 0, it goes to a 0. And you have something that is optimizing the weights in the right direction. Okay, and so it doesn't suffer of the sum of square. And you see here, I don't have sum of square, so there is no issue of a point that is far away that would corrupt the model in the wrong direction. Here, I just want to be sure that a 0 is a 0, a 1 is a 1. If I make a mistake, it's not the baddest thing, but you see it's much better than the linear regression. Okay. Yeah, and so maybe one thing also is that when you plot the loss, the sum of squares, so this is the loss we had for the linear regression. Sum of squares, when you see the loss in function of the weights, so I just say it to you like this because I mean, you should take derivatives, etc., to see how it works, but you would have something that is not convex. You have a lot of different minima. It's not a good function, but when you take the loss with the logarithm, so the log likelihood, you have a convex function. So you have something that tends to a global minima. So keep in mind that this is a much better loss function than what we had before. Any questions about this part? So, and that's again, I want to stress on that. When you define a model, it's always two equations. You have the idea that we have defined here, the output to be this function. So, or let's look at graphically. It's a linear function followed by a nonlinear activation that gives me the probability between 0 and 1. So this is my function, and my loss is this. So this together with that forms the logistic model that, let's say, modelizes the probability of being class 1 or being class 2. Okay, so the idea is that I just want to explain you so I just explain you the rationale behind that model. In practice, what we will do right now, and this is the next homework you will do. I will not give it today because you still have the last homework, so I will give it, I think, tomorrow, is that we will not re-implement this by scratch. We will not code this inside Python. I think this would be too boring to do again. So here, the next notebook will be more practical. You will import from scikit-learn the logistic regression, and we'll try to just play with data and make a simple fit. So from the outside, you don't see all these equations. You just see model, data, fit, predict, etc. But I think it's good to keep in mind that you, behind the scenes, you try to optimize these kinds of equations. So next notebook will be more practical using the scikit-learn library.
So I have a question.
Yes.
Maybe advising, if possible, I can wait for the second lecture with Laio. So this is very interesting. For example, in my area of research, I work with biological systems.
What?
Biological systems.
Okay.
Biological system. So, for example, I am interested to classify. I have a set of small molecules that I want to classify them as the good inhibitor of a certain protein and the not likely to be good inhibitor of the same protein.
Okay.
So the idea I have is that maybe, so I need to, okay, how do I go about now selecting, now getting to the thing that, okay, this will be a
good model?
Yes.
Okay, so
yes.
I think so. I don't really want to answer your question right now because I want to see a bit of the other models, the neural network, and then see the part about how to select a model. So the idea is that I present different models.
Okay.
And the next step is, and this is really a crucial part of machine learning, is that you will want to try different models and do a selection on what is the best model. And the best model is defined on, probably you already know this, you do a test set or you do a validation set and you see how well it works on the validation. And the model that has the lowest score or the highest, depending on what score you want to optimize, but you take the best model on the validation.
Okay, so let me keep with you for the next days.
Exactly. But please, I love to discuss about this. So keep your question above, and we will discuss that. But
yes, sure.
I mean, we are still at the beginning somehow. We still have 4 lectures, so
no problem.
I think it will be clear at the end.
Sure. Thanks a lot.
Pardon, I have a question. If possible.
Yes.
Normally, I understand classification gives us categories or classes, and a regression gives us an equation of a linear style. But something interrupt me. Now we use a regression for classification.
Yes.
In terms of conceptually, and this is something, it comes strange for me.
Okay, so keep in mind that what's important to know is that, okay, mathematically classification is not far from regression. So often the model behind it is a continuous model. So it's very similar. It's almost like a regression. But we want to regress between 0 and 1. That's often the difference between regression and classification. So let me explain it again. You have a regression problem. Then you say, okay, I map my values between 0 and 1. And the next modification I do is that I change the loss function to be this log likelihood function. So the one I introduced today is called the log likelihood function. This is one that really sees the data as a probability and wants to maximize the log likelihood of seeing the data. So by changing the activation between 0 and 1 and changing the loss function, you make you go from regression to classification. So it's not really that different, you know. But
thank you.
The 2 changes make a big change on the result, of course. I mean, a big mistake, it's not a big mistake, but is to do what I just did in the beginning. Is to say, okay, I take a regressor, for example, linear regressor, or I take a neural network, or I take a random forest, whatever. I see it as a regression. I put 0 and 1s on my different targets, and I do optimization of the root mean square error. I take the optimization of, let's say, the average the mean absolute error, so the MIE is another one. You could do that, but technically you don't really see it as a probability, and so you don't really see it as a classification, but it's still working. Yeah? Okay.
Just a quick one, sir.
Yes.
On my end. I'm not necessarily a math person, and I see there are so many.
Sorry, I don't understand you. There's a terrible. I don't. There is noise on your microphone, basically.
Okay.
Can you put the question in the chat, please?
Hello.
Yes.
Can you hear me better now?
Yeah, it's much better. Thank you.
Okay. I was saying that my background is organic chemistry, so the maths, I haven't done maths in a very long time, so I get lost in some of the things that I'm trying to follow. But I just wanted to find out, how important is it for me to understand the nitty-gritties of the mathematics here?
It's not important in the way that I'm giving this because I want to be like, you know, as complete as possible, so that you see that machine learning is basically a mathematical formalism with a function, a loss function, that you see what's happening. But in practice, what you really need to do, so if you don't understand this, it's not a problem. It's good, but it's not mandatory. But what you should really be good at is the notebook. So you should be able to play, not this, the first notebook is again a bit mathematical, I guess, but the notebook, the next notebook is very important. So the second one will be very important because it's scikit-learn, it's opening data, and there will be another one about cleaning data. This one will be very important. So I would say don't put too much attention on the math and the first notebook, but the other notebooks will be important.
Okay, because I was getting worried because
no, don't worry. So, yeah, I want to be clear for all the people lost in the mathematics. Don't worry. I mean, you will see from the next notebooks, the basic key point will be a model, fit, predict, and the basic application is very simple. So if I would just explain you the application, it would be too fast. I want to be quite general enough. So, but don't worry.
Okay, thank you very much.
Okay, if there are no other questions, I will stop here. So no questions? Okay, perfect. I will stop the recording.
I have a question about the homework. Is there a deadline for the homework, the first one?
So this I don't know. I have to see with Omololu what he wants to do. So I don't know if he's still here.
Yeah, Pierre-Paul, I'm here.
Okay.
We'll give a deadline, and then Pierre-Paul will quickly and send to you for the first one.
Okay.
So I think you should work on it, and then I'll discuss with Pierre-Paul the deadline, and give you a deadline that you can quickly work on and finish it. Yeah.
Okay,
Thank
great.
you.
Okay, thank you.
But I think we will send an email. Yeah. Where is Zoom? I don't find the button to stop recording. So.
Oh, sorry, I can't do that.
Yeah, if you can stop it, and then we will close.